A new treatment is believed to reduce the level of uric acid in the blood of gout sufferers. A study was conducted where patients were assigned to the new treatment or to an old treatment. The results are reported as the number of patients that reported significant reductions in uric acid levels. Does this information suggest the proportion of patients that reported a reduction in acid is independent of the drug type? Perform the appropriate statistical test to make your decision at the 1% significance level. Show your work and write a sentence. Puts your answer into the context of the problem. So the new drug, 90 out of 150, right? So there's a total of 150 people. So this is 90 out of 150 said that they were better. So we'll call that p hat sub n. And so what does that come out to be? 9/15 is that 0.6? So I get 60% of the people improved under the new drug. And under the old drug, right, this is 75 out of 150. So this is 50%. So we'll call that p hat sub old, and that's equal to 0.5. Okay, so we're going to do a two proportion z-test on the difference between these two values. So let's check our assumptions. Do we have an independent simple random sample? And do we have the normality assumption? Okay, well, the normality assumption, right, n times p and n times q need to be bigger than 10, and in this case, n times p is 90, and n times q is 60, and 75 and 75, those are obviously bigger than 10, so therefore the normality assumption is valid. Simple random sample, they're volunteers, we have to assume that we can treat them like a simple random sample, and independence, our sample size is less than 10% of the population, so those seem good. So, now we do the z-test. So z is going to be 0.6 minus 0.5. Oh, before I continue with that, let's write our null. Right? Our null is that there is no reduction. So that means if I subtract them, p sub new minus p sub old, or no increase, is equal to 0. And the alternative is that the new drug is actually better. So p sub n minus p sub old is bigger than 0. All right, so now let's finish this up. 0.6 minus 0.5, so there's what I observed minus what I expected, which was nothing, right, because of the null, divided by the standard deviation. So what do we have here? We've got 1 over 150 plus 150 times p combined and q combined. So what do we have for p combined here? We've got 90 plus 75 out of 150 plus 150 out of 300. So what does that give me? 90 plus 75 divided by 300 is 55%. So times 0.55 times 0.45. So there's our z-score formula. And so now we're just going to go stat test, and we're doing a two proportion z-test, and we've got 90 out of 150, and then we've got 75 out of 150, and we're checking to see whether or not we're greater than, yep, so calculate it out. So our z-score is 1.74, and the probability that our z-score is as big or bigger than 1.74 is approximately 0.041. So this is a relatively large p-value. What was our alpha level, right? So we were testing at the 1% significance level. So this is larger than our alpha level, so we do not reject the null. So we do not have enough evidence. We do not have enough evidence to suggest that the new drug is better than the old.